Hey, boys and girls, I'm going to read through this graphing informational packet to you. This will help you as you get through the graphing unit. There might be times you need to open up this video and fast forward to a certain part, pause it at certain parts to kind of help you to be able to work through some of the different skills in new vocabulary words that we might come across in the upcoming sheet. So, all right, let's start on the introduction. Welcome to Science, whippersnapper. Wilshire A. Smith here, and I have a distinct privilege of being your host as you're studying graphing. Actually, I'm a cartoon character with a lot of personality, but don't let that fool you. I got this science stuff down pat. I'd like to introduce you to Ophidia, a good friend of mine. She is generally a good helper, but as you'll find out, sometimes she can be quite a bother. So, Ophidia, my friend, if you would be so kind as to get out of the way, we'll proceed. As your host, I'm going to help you out in two ways. First, I need to be sure that we can communicate with one another, so to do that, you'll need to learn some scientific jargon for this unit. Look at the left side margin, and that's where I'll define all of the vocabulary words, which are printed in boldface. Also, each main idea I want you to learn is found in the margin, and just to be sure you don't miss these babies, I'll put stars by them. And there's a catch though. These ideas are asked as questions that you need to find the answer to. Once you'll figure out the answer, you can get a hot little pencil moving and fill in your answer right beside the question. This way you'll have your own study guide to help you study for tests. So once again, welcome to Science. It's nice to have you here. Data. Let's get down to business at hand. Data is information, pure and simple. Data is information. Look at these examples. Magic Johnson's height, the number of centimeters of snow that fell at Timberline Lodge every day for a month, the number of kilometers from New York to Los Angeles. Each of these items is a little bit of data, or numbers. Scientists use data all the time. Data helps predict the weather, improve stereo equipment, and aid in the fast recovery of patients in hospitals. But it doesn't stop there. The list goes on and on. As scientists, you'll need to be able to record information, evaluate experiments, and draw conclusions. To do all of this, you need to know how to use data tables and draw graphs, which is exactly what this unit is about. Data tables. If we collect just a little bit of data, it's no problem to keep track of it. But what happens when we get a lot? Right, our organization improves real fast, and to organize data, we use a data table. Here is a data table constructed for an imaginary science experiment. Data tables begin with the title. The title of this data table is The Heating of Compound X. The title tells the reader exactly what the data table refers to. Without a title, it's possible the person studying the data table wouldn't be able to figure out what all the numbers meant. And that can be very frustrating. When you construct a data table, always be sure to begin with the title that describes the data that it contains. A data table includes variables and units. A variable describes what information you're recording. A unit tells how you're going to measure that variable. You can see here, variable is the unit. What, how. Looking at the next data table here. In this data table, the first column of data is the time variable, which is recorded in units of minutes. It's easier to figure out the units because they're always in parentheses. The second column or row here is for the temperature variable measured in degrees Celsius. Think of variable and units in these terms. Okay, so this is time in minutes and temperature in degrees Celsius. Data is organized in a data table. If you look carefully, you'll find the numbers are organized in groups called ordered pairs. They're called an ordered pair because the numbers always go together. It's easy to tell ordered pairs in a data table because they're piled up on top of one another. Look at the data table and you'll see that the combination of 2 minutes and 23 degrees Celsius, 2, 23, is one ordered pair, 2, 23. And over here, the next one right here, 5 minutes and 45 degrees, 5 minutes and 45 degrees is written as 5, 45. There are 11 ordered pairs in this data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see starting right here with 0, 20 is 0, 20. Number 2 is 1, 21, 1, 21. It goes all the way through. Now, if for some reason you find a data table that runs up and down instead of across, the ordered pairs are still there. They're just side by side now. So this is the same table, 0, 20, 1, 21, 2, 23. It's the same thing, just organized a little bit differently. All right, a complete data table. A properly constructed data table follows these guidelines. It has a descriptive title, the variables describing what information has been collected. There's units telling how those variables were measured, the data collected in ordered pairs, all work done neatly. Each time you construct a data table, check it against these guidelines to make sure everything's there. Not only will you be getting great grades, but pretty soon you won't need the guidelines and you'll be producing perfect work without even trying. Reading a graph. By now you're an expert at reading and constructing data tables. Now it's time to master reading a graph. A graph is an exact picture of information in a data table. It's usually a line that shows a relationship between all the numbers in a data table. The following data table and graph are here for the heating of compound X. So here's the data table that we've already taken a look at with the ordered pairs stacked on top of each other. So here is that represented in a graph. So the first one that says 0, 20, 1, 21 is right here. At 0, we don't go over and we go up 20. At 1, we go up 21. 223, 327, 223, 327. We always go over, then up, over, then up. Here's the kicker. If a graph is an exact picture of data table, then everything that's in the data table has to be in the graph. Everything. So it has the same things on there. Notice there's the title. There's the title. Here's your variables, temperature in Celsius on the side, time in minutes on this side. All of that is right there. The secret is knowing what to do with the ordered pairs. Take the ordered pair of 121 and split them up. Place the 1 on the horizontal axis. We already did that. The 1 means horizontal, means you go across, and then you go up, over and up every single time. The first number goes over, second number goes up. The point where these two lines intersect is called an intersection. Okay, we went over and then up 20, and where those, and we make a dot. And then as you do all of those ordered pairs, then you connect the dots at the end. To read a graph and find a data point, simply trace the horizontal and vertical lines back to each axis you found, and you found the ordered pair for each data point. Locating the data point by finding the intersection of two lines is called plotting. Once all the data points are plotted and a line drawn to connect them, you have a simple way to read all the data in a data table quickly. Okay, and we kind of went through that too on how the plotting of a line graph. Always remember to go over then up, over then up. Okay, here's your different axis. When you draw your graph out, you always want to make sure you make the lines right here. The horizontal is always the one that comes across. The vertical is always the one that comes up and down. Notice how then they added in the variables. Here's the one that comes up and down is the temperature, and the time is the one that comes across the bottom. All right. So the most consistent data is going to be the one that comes across that bottom part, or that horizontal too. So you just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's what you see here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the tricky part is going to be labeling that vertical axis as we go through. Okay, looking at your data, you always have to kind of find that range. As you can see here, it says the smallest number is 20 and the largest is 74. So the rest of them are somewhere in between there. So my data, my numbers on the side have to somehow fit numbers between 20 and 74. And we can put it however we want it. We can count up starting at 0. We can count up by 5, 10, 15, 20. We can count up 2, 4, 6, 8, 10. Looks like here on this one they decided to go 10, 20, 30, 40, 50, all the way up to 100, kind of safely getting past that highest number then too. So all of the points then will kind of fit in between. So if you had graph paper and your ordered pair was 1, 21, you would simply go just a little bit over that 21 or that 20 mark on the line. Okay. And there you go. You have your little lines that you plotted, and you just kind of connect those with a line at the very end to show that visual representation of the data that we collected too. There we go. And that is it.